Last year, you will have learnt about addition polymers, where two monomer molecules join together to form the polymer, but you can also have what's called a condensation polymer, and that's where a small molecule like water or sometimes HCl is eliminated to form the polymer. So, one type of condensation polymer is proteins. These are polymers of amino acids. You may have learnt that in biology if you take biology, but um, basically, proteins are just polymers of amino acids. So, an amino acid contains two functional groups. It's got the amino group and the acid group. You can tell from the name. So, it's going to have an NH2 group and also a COOH functional group. And amino acids can join together to form dipeptides using an amide linkage. So, I'll just explain what that means. So, you'll have the two, if you got two amino acids here, they can react together, and what happens is the OH from the carboxylic acid group of one molecule and an H from the NH2 group of another are going to join together to form water, and then the NH2 group and the C11O are going to join together to form a peptide bond or an amide linkage. So an amide linkage, you'll be able to recognize it. It's highlighted here. It's just a carbon double bonded to an O and a nitrogen with an H. So this is what an amide linkage looks like, and that is what joins the two together. So you'll have the NH2 group on this one side, other molecule on this other side, and it's going to eliminate water in the process. Another type of condensation polymer is a polyester. You can probably tell from the name that these are polymers of esters. So if you remember, esters are formed by a condensation reaction with an alcohol and an acid. Polyesters are formed in a similar way. They're also formed by the condensation reaction, that condensation polymerization, but it's between double-ended acids and alcohols. So you're going to have a dicarboxylic acid and a diol. Basically, what this means is it's just going to have the functional group on either end of the molecule. So here, the diol, it's got two OH groups on either side. The acid's got two carboxylic acid groups on either side. And so, the same way that the ester formed, the OH, water is going to be removed because the H is going to be lost from the OH, and the OH is going to be lost from the carboxylic acid group, and those are going to be eliminated to form a water. And because they're on either side, it can form a polymer because these linkages can form between lots of molecules because there's multiple functional groups on either side. So these ester linkages can form on either side between a bunch of molecules and form a polyester. So basically, when you draw the ester linkages, it's just going to have the OH lost from the carboxyl groups and the H is lost from the alcohol group, and that's what forms the water. Another type of condensation polymer is a polyamide. These are formed in a similar way to the polyesters. They're going to be formed between double-ended molecules, but between acids or acid chlorides and diamines. So they're going to be formed in the same way, but instead it's going to be an acid or an acid chloride and an amine. And these, again, they have their functional group on either side, and it's just going to form water between the two groups. And they'll form a long chain, a polyamide, and it's going to form those amide linkages that you saw in the dipeptides. So the hydrogen is going to be removed from one of the NH2 groups, and the OH of the acid or the acid chloride is going to be removed as well, and that's what releases the water. And that's how this amide linkage is formed. So it's the same amide linkage as the dipeptide. Just like esters, these polymers, they can also undergo hydrolysis. which is where you split them adding water. You can sort of think of hydrolysis as the opposite of the condensation reaction because you're gonna add water, whereas the condensation reaction, we were eliminating water, now we're adding water to split them. So it's sort of like you're reversing the condensation reaction. And these proteins, they're going to form different products in acidic or basic conditions. So in acidic conditions, you're going to have the dipeptide here. It's going to be split into the two amino acids, but the NH2 group is going to be protonated. It's going to be an NH3 group instead. Well, it should be NH3 plus, but the plus isn't drawn here, but there should be NH3 plus group. And so, yeah, the OH is going to be added to the carbon to form the carboxyl group, and the H atoms are going to be added to the nitrogen to form the NH3 plus. And it's just gonna, you can do this with any sort of acid like H2SO4, and it's just adding those hydronium ions. And in basic conditions, it's just going to be an NH2 group, but it's going to be the carboxylate ion instead. This is because the hydroxide ions, the OH, they're being added to split it. Polyamides, these can also be hydrolyzed, but these ones can only be hydrolyzed in acidic conditions. You just heat them in acidic conditions. This could be heating it with H2SO4 or just H2O slash H plus. You can just write that. That just means acidic conditions. And it's going to split it into the monomers, just like the dipeptides. So it's going to form the original dicarboxylic acid and the diamine, except the NH3 group is going to be protonated, remember, because it's in acidic conditions. That NH3 group is going to be protonated. So it's just going to form, here's the original diamine, and here's the dicarboxylic acid, and again, it's going to split it at this amide linkage by adding the hydronium ions, the H3O plus. And it's basically, you're undoing the polymerization. So it's going to add the OH to the carbonyl group and add the two H plus atoms, or yeah, to the NH3 group.